Assalamualaikum and welcome to our group presentation for the SIEM using Elastic Kibana. We use Kibana to build a series of panels that visualize patterns and events in the dataset. All these panels are grouped into relevant categories, which is threat type, traffic over time, network behavior, organization behavior, geography analysis, IP tracking, and overall activity. First is risky event detected. This pie chart shows the distribution of risky event types by severity. As we can see, DDoS and normal event dominate the logs, but we can also see smaller portions of high-risk threats. It shows the percentage events like DDoS, ransomware, phishing, brute force, malware, and SQL injection, along with their severity levels, low, medium, high. This helps us quickly understand what types of threats are most common in the dataset. This metric panel simply shows the total numbers of logs ingested into the system. This gives us an overview of the data size we are working with. This is our event severity geolocation map, which displays where events originate based on country codes and their total number of occurrence. The map uses a color-coded heat scale to represent event volume by country. From the map, we can quickly spot attack origins. For example, some are red indicate over 33 events from a single region, which is sign of repeated or coordinated activity. This helps us focus suspicious operational behavior based on geographic sources. These data highlight organizations that are involved in or affected by critical event. We use fields like source organization, event type, timestamp, and the count of record per day. As shown, Johnson appear multiple times across different dates and associated with normal traffic, but also DDoS and SQL injection. It could be both a target or a source of anomalies. This table focuses on IP relationship. It lists top 5 values for both source and destination IP address, their event type, severity level, and count of record. From here, we can identify suspicious IP involved in repeated DDoS event from multiple source IP. This IP becomes our primary indicator for investigation next phase. Next is protocol that includes DNS, FTP, HTTP, HTTPS, and POP3. Each bar represents the count of record where that protocol was involved. From the chart, we can observe that HTTPS have the highest usage while POP3 which is the last. This line graph shows how different types of events occurred over time. X is time, Y axis is count of record. Each color line corresponds to a different event types. This panel is useful for detecting spikes. For example, if we change the date, the data will be different depending on what attacks are occurred during that time.
Hi and Assalamualaikum. My name is Sofia Nadira and I will be presenting about the monitoring and detection phase. In the monitoring phase, the Kibana dashboard is used to visualize and track various system activity logs. So to start, the date range is changed to focus on logs from 14 to 15 December 2023, so that it allows the dashboard to display only relevant data for that period. The total number of events collected is shown in the count of records, which reflect live updates based on network activity. The dashboard provides insight into different types of logs, including login events, which are categorized into types such as normal and brute force. Suspicious network traffic is displayed using visual tools like the risky event detected pie chart, which break down threats such as DDoS, phishing, brute force, and SQL injection. The bar chart presents the top 5 protocols being used, for example, HTTP, DNS, and FTP. And also the line graph tracks how many events occur per hour, helping to observe traffic patterns over time. The map also shows where the events are coming from globally, helping to detect possible external threats. So to demonstrate monitoring in action, a filter such as event type DDoS is applied. Once entered, the dashboard updates automatically. We can see that the count of record adjusts, the line graph focuses on DDoS activity, and the pie chart and IP table update to reflect only DDoS related logs. This shows how Kibana enables real-time monitoring of specific event types, helping to spot early signs of suspicious activity. Next, in the detection phase, visual data from the Kibana dashboard is analyzed to identify patterns that may indicate threats or attacks. For example, in the event logs table, repeated failed login attempts from a single IP address suggest a potential brute force attack. The line graph displaying events over time help detect sudden spikes in activity, such as a sharp increase in DDoS events, which may point to ongoing malicious actions. The geolocation map reveals access attempts from unusual or unexpected regions, which can signal unauthorized external access. In addition, the pie chart label risky events detected shows the type of threats detected, including SQL injection, phishing, and brute force, helping to categorize and assess the severity of incidents. To validate these findings, a suspicious IP address such as 185.94.111.1 is copied from the logs and checks on VirusTotal. The result confirmed it is flagged by multiple antivirus engines, proving it is a real threat. This analysis helped confirm that the anomalies seen on the dashboard represent actual security risks. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuradina binti Alias. So today I will presenting about investigation phase. I use the ELK stack, especially Kibana timeline features, to identify suspicious pattern in the security events. One of particular pattern that stood out was a series of high severity ransomware event. This alert occurred between December 14 and 15, 2023. I traced the IP address 183.136.225.32, which appear multiple times in the logs. This IP was consistently involved in ransomware-related activity. The method used in these events was classified as ransomware, indicate that the attacker likely attempt to encrypt or disrupt file within the network. To validate the risky event detected in Kibana, I used VirusTotal to investigate the IP address involved in the incidents. First, I tracked a ransomware attack marked with high severity. I suspect that the IP address was malicious. And after checking it on VirusTotal, it was confirmed to be tried. This means it was a true positive where the system correctly detects a real malicious activity. Next, I select a malware event also marked with high severity. However, the IP address turned out to be clean according to the VirusTotal. This makes it a false positive where the system flagged something as a threat when it was actually safe. Then, I look up into a normal event with low severity. The IP address was verified as clean on the VirusTotal. This is a true negative, means the system correctly ignored something that wasn't a threat. Lastly, I investigate an IP address involved in a phishing attack labeled as low severity. I expected it to be safe, but VirusTotal showed it was malicious. This is a false negative where the system failed to detect a real threat.
Assalamualaikum, my name is Neo Muhammad Syahmi bin Hamdan. Today I will explain about the escalation pipe. The IP is 183.136.225.32, which has been identified with a high severity level and labeled as malicious. It is involved in phishing, malware delivery, and brute force attacks. This IP has been reported over 43,000 times in global threat databases for port scanning, SSH brute force attempts, and probing of critical ports like 22, port 445, and port 3389. This behavior are typically seen in automated botnet, reconnaissance, or malware staging. The action taken in response were firstly blocking the IP at the firewall, IDS, IPS, and email gateway, monitoring for repeated access, attempt on vulnerable ports, reviewing and hardening system exposed to the internet by closing unused port, enabling MFA, and applying security patches. Next, implementing IP reputation and geolocation filtering to automatically drop traffic from high-risk regions. This attack fits meter attack techniques such as active scanning and brute force, making it a common but serious prelude to deeper network compromise. Our rapid response in this case is crucial to stop lateral movement, credential theft, or unauthorized system access.